Okay, finally. So we have our next speaker, uh, which is Roy Berkovich. His topic for today is same code, faster application. Like we already discussed, the apps need to be fast, need to be very smooth these days, and Roy is always like going to help us do exactly that. Quick info about him: he has been working in the technology domain for past 5 years. He's working as a software engineer, and he's focused mainly on React and JavaScript. He works with a company called Apps Flyer, and he joined them a year ago. He's always looking for ways to create high quality code and deep dive into the technologies and frameworks. He also writes a tech blog at the rate reactisrael.co.il. And he's also the founder of JS Snippets Facebook page, which has a whooping 15K followers. So, yeah, Rui, over to you, and great to have you here.
Hi everyone, let me share my screen. Can you see my screen?
Everything is working. Yeah, you can start.
Okay, so hi everyone and welcome. I'm Roy Berkovich and today I'm going to talk about how we can make our app much faster without almost changing our code base. I'm a senior software engineer at AppsFlyer. For those of you who don't know AppsFlyer is a mobile app tracking and attribution analytics platform for app developers and marketers. We help our clients to measure the return on investment of the marketing money they spend. So basically, we use data and a lot of data to save our clients money. I also write a tech blog called React Israel. There I write about almost everything related to React, React Native, and JavaScript. And I'm also the founder of JS Snippets. It's a Facebook page with 15,000 followers. If you like JavaScript snippets and squeezes, this is the place for you. You can go and check it out. So React is great. I believe that most of us work with React because we are in a React conference, of course. When creating a new project, everything is super fast. We have excellent performance. We have quick updates, both for state and props. And we also have React Memo, use callback, pure component, and a lot more cool stuff that help us to develop a great app. Our bundle size is pretty small. We have some libraries, some modules, and maybe 3 or 4 outs. But as we continue to develop, our application gets bigger and bigger because of new features, new components, new libraries we add, new modules, new tools that we had. So the more the code we write and the more libraries and modules we use, our app bundle size will get bigger and bigger. This is something we can't avoid. Everything goes to the main bundle. We can't do anything about it yet, right? Now let's see some cool stuff. So let's begin with how can we know that our bundle is too big if we don't know that we have a problem? So we can find out the easiest way for both development and prod is to check the network tab in our browser. Here we can see the bundle size of our app. The second way is to build our project with a yarn on npm, then go to the dist folder and search for the JavaScript folder. That's where we can see our bundle file and see its size. And another way we will know if there's a problem is if we see this warning in the CLI when we build our app. This warning will only appear if our bundle size is too large. Only if you use create React app, of course. This they're running. So before we continue, I want you all to remember this sentence. Always think of your users. We are probably working in a high-tech companies, startups, and big corporation. We probably have a brand new Mac and super fast Wi-Fi in our offices. Everything works like magic. We have a great app that's worked perfectly, and we are super proud of our amazing app. And yeah, we are using React. We have a single page application. We are awesome. But some of our users are stuck with poor internet. For them, our application is not as fast as we think. So remember this, we develop our apps for our users, not for ourselves. Even if it works well at our end, our users may have trouble. Okay, our bundle is too big. Where do we start? So the first thing we need to do is to analyze our bundle. Just for that, we have two leading libraries that do almost the same thing. They analyze our bundle. We have Webpack Bundle Analyzer and Source Map Explorer. Today, I'm going to talk about Webpack Bundle Analyzer, mainly because I like this library the most, but you can work with any library you want. It doesn't matter. So what does this library do? It visualizes size of Webpack output files with an interactive zoomable tree map. Now, let's see an example. Here we can see what packages our bundle consists of, and we can analyze it. At first glance, we can see here that Lodash, Mobex, and Bluebird take a lot of our bundle size just from the size of their boxes, okay? You can see when we hover the boxes, we can see the path, we can see the stat, we can see the gzip, we can click a component and see all our children. Because we developed this app, we know that Lodash just recently added to our project and that we used it only in one place in our app. And that place isn't even used very much by the users. So why is it taking so much from our bundle size? We definitely don't need it to load on the first page. Okay, let's summarize what we can achieve with the tool. We can realize what really inside our bundle. We can find out what modules make up most of its size. And we can even find modules that gather by mistake. We want to test a library, we install it, we try it, and then we decide not to move forward with that and to replace it. But we forgot to delete it, so it's still in our bundle. Okay, we identified the problem, and we have analyzed our bundle. And as always in programming, every problem has a number of solutions, okay? But today I'm going to talk about one of the solutions. It's named code splitting. Code splitting is a feature supported by bundlers like Rollup and Webpack. They can create multiple bundles that can be dynamically loaded at runtime, okay? Code splitting our app can help us lazy load just the things that are currently needed by the users. And this can dramatically improve the performance of our app, while we haven't reduced the overall amount of code in our app. Remember the title of my talk? It's the same code, but we get a much faster application. We avoid loading code that the user may never need and reduce the amount of code needed during the initial load. this is how code splitting works. Instead of loading our bundle in one piece at the beginning, we split our bundle into multiple bundles and load them on demand in runtime. How can we do it? So the best way to introduce code splitting into our app is through the dynamic import syntax. The dynamic import syntax is just a JavaScript, is part of the ECMAScript, and when Webpack come across this syntax, it automatically splits our bundle to chunks. Dynamic import is basically returning a promise, and the resolution of promise is expected to have the module, and then we can use it. We can see how we used to import. We import add format and then use add, and we can import met with dynamic import, and it's return a promise. But if we will do it, we also need a catch, and our code will not look that good. Okay, so it's hard to work with the native JavaScript dynamic import inside our React app. Just to clarify, code splitting and dynamic import are not limited to React. We can use them in any application. It's only a matter of implementation. Now, let's see the React way and how we can do it. In version 16.6, React introduced lazy and suspense. And this is the place where all the magic happens, okay? React Lazy. React Lazy is a function that lets us render a dynamic import syntax as a regular import. This will automatically load the bundle containing the component when this component is first rendered. After the first render, our bundle files are cached. So if we use the same components again in a different page, we will get the bundle from the cache without having to download it again. This is the lazy function syntax. React Lazy function provides us a built-in way to separate components in an application into separate chunks of JavaScript, of course, with very, very little legwork. We just change the way we used to import the component. You can see the first line, we just import my component. And in the second line, we use React Lazy and pass the path. Now, this is the simplest example of React component, I think. We don't see anything special here. It's just a dump component that is rendering another component. And this is how we usually write our imports today. Now let's see React Lazy in action. Here we can see the exact same component. The user's components are identical. The only thing that has changed is the way we import the component. We can see it in line number 2. In the previous slide, we used a regular import like we always do, and now we are using React Lazy. So what does this code do? It will split my component and all its children into separate bundle file. And we will download this bundle only when we want to render my component. Okay, now we have 2 bundles, the main bundles and my component bundle. We must understand that when we had one bundle, we just loaded it and all our imports were synchronous. But with React Lazy, we get our new split bundles on demand and download them. So what will happen while you are waiting for the lazy component to load? Just for that, we have React Suspense. React Suspense allows us to show a fallback UI because it's asynchronous. We can show a fallback UI like a loader or a spinner while you're waiting for the lazy component to load. All we need to do is just to wrap our lazy component with React Suspense. Let's see it. This is the React Suspense syntax. React Suspense has a prop called fallback. The fallback prop accepts any React element that you want to render while waiting for the component to load. Just a second. Suspense accepts at least one component that is lazy, but we can add any valid JSX in addition to the lazy component, and we will see the fallback UI until it's finished loading. Okay, we can group some components and we will show the loader until it's finished loading. Now let's go back to the previous example, and it's the same code. Now we just import Suspense from React and wrap our lazy component, and now we have a fallback UI until the component will finish loading. We can even wrap multiple lazy components with a single Suspense component. Now, it's important for you to understand that we will see the fallback UI until all lazy components finish loading. I think you can think of it like something like promise all, okay? Okay, Biget. Error boundaries. Okay, our error boundary is related to code splitting. Well, lazy loading is an asynchronous. So if the module fails to load, for example, due to network failure, then it will trigger an error, right? Remember, lazy components are asynchronous. We can handle this error with error boundaries and show some recovery UI or an error message. If you haven't come across error boundaries until now, it's okay. I recommend that you read about it. And don't worry, I have added a link about error boundaries at the end. This is a full example of how our code should look. And these are the steps. Change the import to lazy. Import Suspense and wrap our lazy component with Suspense for loading statement, of course. And then wrap it again with error boundaries for catching errors at runtime. Now let's see a real life example. Okay, just 1 second. Before that, what should we split? Okay, we can split components, so it's great, but can we split more things? Sure. We can begin at the route level. Routes are the simplest way to identify points of your application that can be split. We can also identify any large components on a page on your site that only render on certain user interactions, like clicking a button and open a pop-up or a dialogue, or something that the user don't see because we have a flag. And we also need to consider splitting anything else that is off screen and not critical to the user, because we don't want the user to see a lot of loaders everywhere. Even if your app will be faster, the user will think that it's slower because you see a lot of spinners all the time. Now, let's see an example. And the first place we need to think of when we want to split our code is our routes. The bigger our app, the more the chance that we have some routes that the user almost never visit. For example, let's take GitHub. When was the last time you edit your profile picture, changing your address or the place you work? Probably not very often, right? So this is a great route for code splitting. The user don't need to load it at the initial page. And in this example, we will see two routes. The main route that is very slim, the home page. Now let's go into the home page. We just have an image, a paragraph, and a link. Okay, very, very slim component. And we have the heavy component. And here you can see that I have a map data and hide charts and React PDF. Okay, so it's a pretty heavy component. Now we can see our main bundle size before code splitting is 1.8 megabyte. Okay, we can navigate to the heavy component route and see that we don't download anything. You see, all our application code has already been loaded, even if we don't need this component. We load everything. Now let's see how to split our code into chunks. As I said before, all the difference is how we import our component, and React will take care of the rest. Here you can see the regular import. I change it to React Lazy and import the same path, and I wrap it with suspense. Now let's refresh. Okay, are you ready? 429 kilobyte from 1.8 megabyte. Okay, this is truly amazing. Our main bundle is now 429 kilobyte because we split the heavy component, just it. We didn't touch our code base. We just save our users 76% from the original bundle size just by splitting the one route. Okay, we must know our application and how we build it and what is important to the user. You with me? It's 4 times faster than the first time we tried to load the main page and without changing the code base. This is huge difference to the users. Now let's see the new bundles file. Only when we navigate to the heavy component route, we download the new bundle file. Okay, you see? We refresh the page and now we can see the new bundles. It's 1.3 megabyte and 29.1 kilobyte. And some of you have noticed that the chunk names was 0, 1, and 2. This is not readable. It's not readable. What will happen if we have 10 lazy modules, 20 components? It will be very, very hard to debug. So we can change the chunk name with a special Webpack comment called Webpack chunk name. And we write the name that we want to see in the network tab. Now let's see an example. Here you can see how I added into the lazy component. And okay, just a second. And we will see that name in the network tab, heavy component. Let me refresh the page. And now you can see heavy component and the vendors of a heavy component. And if this module fails, we will know which lazy components failed in the network tab, and we won't need to guess. Okay, we saw how to split our app bundle when we had a problem, but we don't have to wait until our bundle gets huge. We can check our libraries and modules before we install them and make smart decisions. Let's see some tools that can help us with that. So the first one is an extension by Wix called Import Cost. It's for VS Code. This extension will display the size of imported packages inline in the editor. The extension actually utilizes Webpack in order to detect the imported size. Here we can see a classic tree shake use case and understand how it makes our bundle bigger or smaller. It's 2K or 70K. It's a lot of difference, okay? Just by how we import our modules and our libraries. The second one is called Bundlephobia. It's a website, bundlephobia.com. In this website, we can find the cost of adding an NPM package to our bundle. It can really help us when we want to add a new package to our project. If its cost seems terribly high, it might be worth considering another package or writing the code ourselves. Okay, we can even choose the library gzip or the minimum, or how the bundle is minified, and also to see the version. Here we specify a version, and we can see another version of the same library. Okay, as I said in the beginning, always think of your users when you write code. We don't want to see a lot of loaders everywhere, and we definitely won't want a slow app. So be careful and don't start lazy all your components and all your routes, okay? Be wise, guys. I hope you learned something new, and please go and check your project and see what you can split to separate chunks. You can reach out to me on LinkedIn and send me a message. I will be glad to hear about a project that you split. And here are those useful links that I promised you earlier and that helped me in preparing this presentation. Thank you very much. It was a pleasant.
Thanks a lot, Roy. That was a great session indeed. And I personally have used like splitting code a couple of times, and it does impact a lot. So in my company, we have made a standard that we don't do, like, we do absolute imports for Lodash, and we don't directly import the whole package, because it impacts a lot on the whole, the code base and the usability and the bundle size, obviously. So because we have a little bit of time, do you mind taking a couple of questions? There are a couple of questions from the audience. We can just take it.
No, let's do it.
All right. So there was this one question which says that suspense is still an experimental feature, and React talks say that it should be avoided to use in the production. So should we use it or we should not?
Yes, we can definitely use it in production. What is experimental is not this suspense. It's a suspense for fetch and some experiments that React are doing those days, but it's not about this suspense. So it's definitely you can definitely use it in your application for production.
Okay, that's great. That's good news for everyone here. Another question is, how does bundling and lazy loading compare to loadable components?
What do you mean loadable components?
It is a question by Adam. Maybe he can add more things about it. Maybe that might be a library which would be there. Adam, if you are still on there, you could, add more about your question. What do you exactly mean? Any other question? Let me quickly see. Everybody else who has a question, they can, feel free to add it in the comment section. There was one more. So there was one more question saying that the presentation or the example that you gave, it had a 76% decrease in the bundle size. But it is a good question. It says that would it be the same in the production, or it might differ, or how do we, predict that?
Yes, of course, it was a one route, and I want to show you the difference so you can understand that it's very useful. But you can definitely, I think, something like 40% for sure. You can decrease the size of your bundle size.
All right. So there is another question by Rahul. He says that how can we implement a deferred loading? He says that if the user is sitting idle, he is not performing actions. If he wants to load a component at that time, how can one do that?
What you want to do to show a loader?
No, so he basically saying that a user is not performing any actions, and at that time maybe you want to load a component on the page. So how should you go about that?
We can also do something like prefetch for the components. We don't have to load them on demand. Okay, we can make a decision that when we scroll after I don't know 100 pixel, we want to load our next section or our next page because we've analyzed our user interactions and we know that they will probably go to some route. And we can decide that even after some I don't know, after 10 seconds, we will start loading in the background our second route, for example.
All right, that's nice. Another
I see
question.
they ask about SSR.
Yeah.
So this syntax, it's not supported for SSR. Okay.
Roy, can you just tell the audience a bit about SSR first? Maybe not everyone is aware. That would be great.
SSR is server-side rendering. Okay, so if you send your HTML ready from the server to the client, you can't use this syntax, but you can check in the documentation and see what is the alternative. Maybe I can send you a link.
We have another question, Rui, from someone on the senior side. He says that what are the things that you should consider when using dynamic imports? Apart from that, it makes the code look ugly. Is there anything else when you make a choice whether you should dynamically import something?
I think that with dynamic import, it really looks ugly, but with React Lazy, it's super nice, and you just change your import. So why is it ugly?
Yeah,
we don't need the with dynamic import, we need a try and catch and catch the errors. But with suspense and error boundaries, it's super easy.
Okay, that's great.
I'm not agree that it makes our code ugly.
Okay. I would say one last question. We'll do the others in the Q&A round. So one last question is this also beneficial for React Native apps, or is it only in React, the web apps?
I'm not sure. Okay, I don't think it's also for React Native, but I'm not sure.
All right. That was a lot of good information, Roy, and thanks a lot for this session.
Thank you very much.
Yeah, thanks a lot. We'll have him again in the Q&A. So keep all your doubts ready. We can have a lot more questions then. So
Okay, no.
thanks a lot again, Roy. Yeah, thank you.
Bye, everyone. Thank you.